Good morning, friends. This is Shivakkumar again, and so as a part of continuous series on details on instrumentation. So today I like to discuss about power plant instrumentation. I already told the instrumentation and control in power plant is a vast and very diversified. I can say we have a separate boiler plant instrumentation for drum level control, mainstream temperature monitoring control, and then say a lot of control valves are there, say for boiler feed pump, temperature, pressure, flow, and say we have a coal feed actually from the conveyors, right, from coal bank, coal yard to the ball mill, and then actually from ball mill to the feeders, and then actually here actually a lot of motion sensors are there actually. So we, yeah, I mean, adjacent to the conveyor belts we have the proximity sensors. So all that is connected to say if the say conveyor is sagged or it is moving to one side, it will, the proximity sensor placed in the left can track that and send a signal, and say it will stop the signal. Say the proximity setting will have normally we have minimum setting, and if it changes the proximity, then it will get notified to the control room or a local operator, or in connected to the PLC connected in the local control system. So whatever control you are I mean having in your plant, actually based on that it will sense PLC or DCS or anything. So it's a kind of closed loop, right? So and one thing, and then actually the furnace temperature monitoring, and then actually so lot of control. Control valves and lot of pneumatic valves. Actually, say the solenoid movements for tracking the pistons, and then say so those are 110 or 40 for 110 volt DC or 48 volt DC kind of thing. And say in case of turbine, we have lot of power plant turbine plant instrumentation. Say we have throttle valve temperature and pressure sensors, and when the steam is moving from boiler to turbine, when it's crossing each and every stage, right? Normally 28 stages, 12 stages, lot of things are there. So based on the capacity of the unit and everything, so in each stage the pressure will go down, and so actually the steam pressure reduces, and the final stage it is very low. The entering point stage or initial stage pressure is high, whereas the existing, exiting pressure is very low, because it is impacting the turbine to forcefully rotate to high speeds, right, to generate the electricity. And this turbine is connected to the turbo generator, and then where the power is here actually the I can say the kinetic energy will be can get converted to electrical energy, right, actually. So that is actually we have say turbine thrust pad measurements. A lot of in each stage actually say it depends on your power plant requirement. Say at the different stages of turbine, actually you can place the pressure sensors, temperature sensors, flow sensors, velocity, and then actually we can say in case of actually air cooled condenser, what is the temperature to be maintained there. And like that actually even in motors or a pump, actually we need to have a temperature or a pressure gauge to maintain that. So these kind of instrumentation controls are available. And say bearing temperature, front bearing and lower bearing, all this in case of turbine measurements, the measurements are there, and speed measurements. So everything actually it is very critical in the power plant instrumentation. And so actually we need to have a proper instrumentation and control in this plant, right, actually. So other than that, actually we have say in chemical plant, when boiler feeding, right, actually dosing. So we need to have a proper dosing, proper content of chemicals to be fed. And so we need to maintain proper chemical content to avoid the scaling and everything. So to maintain the scales, we need to have a proper dosing, so everything to be maintained, right. And so for that, actually efficient power plant instrumentation is required. So we are going to see the piping and instrumentation diagram of a thermal power plant, basic process of a boiler, and then fuel measurements, and then review of pressure and temperature measurement, steam and water flow measurements, instrument applications in power stations, and review of indicating and recording instrument, that is data logging, right? And say water level gauges for boiler drums, closed circuit television instruments. In case of say NTPC power plants, they are having the closed loop cameras for for monitoring the inner furnace as well as turbine measurements, and they are monitoring and everything, right? Other than the DCS, so CCTV kind of small camera is there, they will maintain everything. So, indicating and recording instruments, water level gauges for boiler drums, and closed circuit television instruments, gas analysis meters, say for flue gas analysis, and when the gas is exiting the say I can say the big coolant towers, or all these things. Actually we have CO2 NO monitors are there actually in the chimney. All these things can be properly monitored in the local station. And so chromatograph analysis will be there. So gas analysis meters, smoke measurements, say for chimney. We have filtered to avoid chemical contamination or pollutant in the to the nearby environment, right? So we need to set a filter for CO2 NO filters, and monitoring is taken place in the bottom of the chimney. So smoke measurements, dust monitors is required, and then measurement of impurities in feed water, and steam generators, coolant controls, and instrument. So instrument maintenance aspect. So we need to have a proper breakdown and regular maintenance, preventive maintenance. So breakdown maintenance, actually the particular is having fault, then we are going for the breakdown maintenance. But preventive maintenance is required to avoid any breakage or any I can say fault or any mishappenings, I mean wrong readings. To avoid that, we need to have every month. Actually, they will do proper calibration, or once in 15 days, right? Actually, they will do this kind of calibrations and monitoring, right? For the pressure, temperature, level, flow, velocity, all these gauges or dials, gauges, everything. And then boiler control objectives. So combustion of fuels, that is gaseous, liquid, and solid, excess air. So combustion chemistry, and and products of combustion, and requirement for excess combustion air, and calculation of efficiency of boilers, input output methods, so heat loss methods in boilers and turbine, and steam temperature control systems, and superheaters and desuperheater temperature pressure controls. And then we have feed water supply and in the boiler water circulation systems, the drum level control systems, boiler draft system, so to maintain efficient, actually say firing and everything, right? For the steam production and everything, we need to have a proper draft maintenance. Draft maintenance means vacuum maintenance. Actually should be somewhat around actually the prescribed level in the power plant based on your capacity, mean megawatt or kilowatt capacity. So we need to maintain a boiler draft system. So measurement and control of phase draft, and measurement and control of combustion, draft and airflow control related functions. And then we have flue gas analysis, trimming of combustion control systems, combustion control for liquid and gaseous for fuel boilers, coal or solid fuel stokers, and combustion control for stoker feed control for pulverized coal field boilers. And then we have turbine monitoring control, speed, vibration, shell temperature monitoring, everything. And then in case of nuclear power plant, is the controls are most robust, and also we need advanced features in the instrumentation and control and safety features, right? say the instrumentation normally actually will deal with all the safety switches actually, say to detect the over speeds, under speeds, or over temperature, under temperature, or over pressure, under pressure, to prevent damages and distraction, disastrous environment, right? So that is what actually this transmitters, temperature monitors, gauges were used, right, to avoid unpredicted damages or accidents. So even boilers, I can say it's a potential. It's like an atom bomb, potential bomb. It can explode at any time. So to have, we need to have a safety features that is achieved using the instrumentation control in boiler and turbine units. And nuclear plant instrumentations such as piping and instrumentation diagram of different types of nuclear power plants, radiation detection instrument, process sensors for nuclear power plants, spectrum analysis, that is very important. See, in case of nuclear power plants where disasters more and dangers also there, we need to have a different types of spectrum analysis, photos in the photo measurements, photosynthetic measurements, process sensors. So those are radiation detection instrument. So everything to be you deployed while running a nuclear power plant. So the nuclear reactor control systems and allied instrumentations are very critical, and these kind of instrumentations or very high level precise knowledge is required, and it's a kind of rocket science kind of thing actually. So it is not that much easy to enter the nuclear power plant instrumentation, right? So if you are interested to know what are the textbooks available, is BG Liptak Instrumentation in Process Industries, volume first and second, Chiltern Books Company Limited, published in 1973, and Sam D. Duclos, The Control of Boilers, Instrument Society of America, uh, Pierce and Press, and then actually A. Sherry, editors, Modern Power Station Practice, Volume 6, Instrumentation Control and Testing, Bergman Press, published in 1971. So these are the very good books in reference for the power plant instrumentation, control and instrumentation. But again, actually, the power plant control instrumentation is more sophisticated, say, because actually the local temperature, pressure, level, flow sensors. Mm. Sensors will be connected to the local control stations called control equipments called programmer logic controller. Is based on the relays, and where actually this is connected, again connected to the DCS, central distributed control systems, where it will control the DCS will be connected to the process stations where computers will be there. The control unit persons can monitor all the process lively, and so they can easily control, and they will command, they from the control room they will command the local operators to whether to close the wall or open the wall to maintain the pressure or a flow or a temperature, everything, right? They will monitor from the sensor, they will give command to the local users, so they will operate as per the requirement from the control room, and as per the process um, requirement. So in order to they will command actually from the control room. They will command to switch off the fan or switch on the fan, control the cool flow, or if any difference in temperature or draft system, they will ask the operator to check the exact problem, and they regulate the walls. So these kind of operations will be monitored from the central control room and executed. Say some walls are automatically, say in a remote location, in a remote or say very hazardous locations, actually we cannot ask the user to control from the local. So in that case, the DCS will, from DCS they will give command, so this on off control walls can be done, the mainstream walls and everything. So other than that, actually I know unhazardous places actually where actually operator can operate the walls, close, open, close the walls, relays and everything. So, say even in electrical systems also, we can have the control room operator can give a command from the central control room, and then which and the local user can just close or open the breakers, right, circuit breakers and everything in a switch yard and all these things. So this kind of arrangement, say whatever possible automation possible from the central control room, they can monitor from the central or control that, and those mechanical or electromechanical devices which are not subjected to automation will be controlled from the local station, but actually the command will be given from the central control room, and this is achieved using the instrumentation and control, I can say electronic instrumentation control concepts. Without that we cannot do plant automation. So instrumentation is very important in power plant instrumentation. Thanks friends.